Okay, hello everyone. Hello everyone online. It is Monday, March 24th. Okay. And right now we're in week 7. We're going to get to about 11 weeks in this class. That's kind of my goal. And so I know we've missed a couple of weeks. I was ill one week and then I had a conference another week here. And like I was saying to some folks here, I'm going to try to go to about 6:30 today just because I got a 5:15 a.m. flight tomorrow morning. So I got to wake up at like 2:30 or something like that. It's going to be long. I'm going to sleep really well. But I'm staying at the MGM Grand, like the casino in Detroit.
Oh, nice.
Yeah.
It's nice.
What's that?
It is nice. The engineer brand.
Yeah, okay, I'm staying there, so I'm excited about that. Oh, excited about that, and there won't be any college basketball to gamble on, so that's, because I'm going Tuesday, Wednesday, Thursday, so. But, okay, couple things I'll mention here. Today, we're gonna talk about open science, so we're not gonna do a whole lot of programming. We're gonna do open science, and actually, one of the assignments isn't available right now through NASA TOPS, because so that website, and Philip pointed that out for me, that website isn't open, so everyone's gonna get credit for that. So there's gonna be just 2 assignments with open data. And we're gonna talk about the ideas of open data, fair data, care data, open data hubs right here, and what we call the democratization of data these days. So I'll talk about a couple of examples and kind of look at some other things. But just recapping last week we talked about R. If you want to go through, bring in your own data sets. The good thing about R is you can kind of run these scripts, write them once and run them just like Python programs. The Python programming is a little bit harder because you've got to kind of associate input parameters such as drop downs and text and all those other things and figure out what those properties have. Because if you input a text, well, you got to convert that to a number first and then do your programming. Where that with R, you just read the data into a CSV and you can do that. I found this neat book here. I've kind of utilized this before, but this is for folks here. But this is Learning Statistics Using R. One of the good things I like about this book is that it kind of explains about central tendency, dispersion, graphing data, statistical testing, hypothesis testing. And that's the big thing these days is hypothesis testing. And some of the things like hot spots and cold spots kind fall right into that. What would be an example of a hypothesis? We do hypothesis testing. What's an example of a hypothesis?
An example, like if you're gonna try to do something and you expect a certain result.
Okay.
Right?
Just we make these statements. Exactly. We make these statements. Cancer rates are higher in low-income areas compared to higher income areas.
Yeah.
Okay. COVID rates are higher in urban areas compared to rural areas. So we make these statements that we can really compare using distributions. And last semester in geostatistics class, we kind of looked at, all right, what is high income mean? What is it, over $30,000? Are we going to split it into quartiles or whatever? Above the mean, below the mean? What's the definition of urban versus rural? Just any zip code that's 15 miles from a city. What's the definition of a city? So we kind of play with those because next week we're going to start looking at quote unquote big data. Now we're just going to look at 100,000 death records. We're going to look at a couple 100,000 crimes. To be honest with you, that's not a whole lot, but we can start to merge these together because we can merge tables together in ArcGIS Pro that are basically they have nothing to do with GIS data. I can just bring in multiple tables. So I can bring in like multiple death records throughout the years from the Vital Statistics database and merge them all together. Now, the big problem with the death data is that in about 2014, they changed their schema. So they changed the names of the actual attributes. But you can do something called field mapping where that it's, you can do attribute mapping or field mapping. We used to call it data loading in the old incarnations of ArcGIS, it wasn't called ArcGIS Pro, called ArcMap, where that I can map, all right, the thing that says DTH county is now D_county. And so you can say, all right, I'm going to load it into that from this old one. So I can kind of put together one set of data, merge one set of data, merge another set of data, and combine those. because those get real tricky, because a lot of times, with a lot of these projects, you just get these from me. Mulrooney gives you all the, the cancer deaths and you go with it, but it took Mulrooney a long time to go and make that cancer data, or the zip code data, or, I've got zip codes with income, percent Democrat, percent Republican, COVID rates. Those just didn't magically appear. And so there's been some kind of pains that went in to create those. So next week, we're gonna kind of look at some of the pains that it takes to create some of these data, and we're going to talk about statistical testing, all those other good things in kind of 1 week, and look at hypotheses. And I think next week you're going to create a hypothesis using, spending patterns, COVID rates, some of these other things. Just make one general hypothesis and make an assumption. And the one thing about this class is it's okay if it's wrong. Like, I don't mind if it's wrong. You know what I mean? If we say, I'm going to make a hypothesis that says COVID rates in urban areas are higher than COVID rates in rural areas, and you do it for a 10-mile buffer, and you're like, oh, darn, I found the exact opposite. All right, let me change it to 15 miles, and let me see how it does then. All right, let me put it to 17.3 miles and see how it does then, 25 miles, And that's what people do when they go, what's the definition of an urban or rural or whatever? Because typically, and we talked about these last week when we looked at the definitions of urban and rural a little bit, was that we've got we got the metropolitan, we got something called micropolitan, and now we've got rural. And then when we kind of looked at things like RUCA's, rural urban commuting patterns, there were like 9 different categories of ruralness to urbanity. So I thought those were kind of neat. But nonetheless, this is a great book. It explains the statistics a lot, and it talks about some of the commands and modules and all that other good stuff. I like when books do exercises and they explain stuff, but I don't like just reading books. I like kind of looking at exercises so I can, go type in this command, and at the same time, I'm looking at things like alternative hypothesis, things that we've talked about. Alternative hypothesis, we're just comparing 2 distributions of data, basically 2 bell curves, and those medians are far enough apart, we can say they're statistically different, and depending upon our hypothesis. So some of the things that we looked at last week, bringing your own stuff. Also this week, I was at the North Carolina GIS conference. I'm going to highlight some of the great work that we did. And so I wasn't here Wednesday, Thursday, Friday. I was at that conference in Winston-Salem. And then this week, I will be attending the Association of American Geographers Conference Tuesday through the rest of the week. So I will be gone the rest of the week, beginning first thing tomorrow. So I've helped out some people print out posters for next week. And then Dr. McGinn in our department, you guys know Dr. McGinn, right? He's in the office over there. He's got the plotter because I think he went and took it because people are already asking him. And so you can go and ask him, and he'll not ask him to print it. You plug it in and figure out how to print it. It's something called ArchE, which is basically 36 by 48, and you click the little button that says fit, so that it's not like putting off, just make it fit. So if you happen to have something that's 36 by 49 or some of these weird metric things, just make it fit. Make it fit to 36 by 48, because the widest our printer goes is 36, because I think the template they sent out was 30. They had some weird size. It was something like 36 by 50 or something, 45 or something like that. And you can stretch that out, and that's not too bad. Just print it out 36 by 45, print it out at 100%. You don't even need to fit it because we're not squishing anything. It just won't go the extra 3 inches, because you could print it out 36 by 105, but I don't want anyone to do that. And then also Dr. Grant, print it out. So like I alluded to, I will not be able to make it to GERS. So go have fun, present, all that other good stuff with the posters. And I had one of our students, I think he might be joining us online right now, one of our students come and give kind of a dry run. If you give an oral presentation with PowerPoints, how many people are doing oral presentations? And we're doing oral, and we just got all posters here. For oral presentations, those of you
I'm
joining
doing
us.
oral.
Okay, good. Oral presentations, make it look pretty isn't the right word, but minimize the white space. You know, you can see some of my presentations I've got here. Oh, not this one here. This is one that I created a long time ago, but I've gotten really good at doing PowerPoints. And this is the thing that I'm given next week. I already kind of talked about this already, but you know, minimize white space, maximize contrast. What's this word contrast mean? Difference between brightest and darkest. I don't like putting like oranges on blues and all that other stuff. Keep it simple. I have things like green. What do you think green means on a map?
Good.
Good. Red means bad. You know, all right, good food, bad food. And I work really hard to, you know, there's not a whole lot of long stuff you have to read right here. I maximize or minimize the white space right here. So there's not, you know, this text isn't really small. And of course, fill it with maps. You know, I've got the results. What do people want to look at? You know, X bar, and then we got a little Z scores and all these other things right here. And then I tell them the little results right here. I've got like 3 or 4 different results. I tell them what happened. So I just want to make sure, you know, you go out and present. When you've got a poster, the maps, that's what we care about. Attention to detail is what they care about. I've been a judge before. One of our faculty members is going to be a judge. So a little attention to detail, meaning you've got different fonts on the poster. Don't have different fonts on the poster. Have it all as the same poster. If you go in one little tab for one set of things, go in with one little tab the other set of things. If you use a little circle for bullet points, don't use a square for something else. Use the circle. Okay, so those are going to be, you know, just important. Attention to detail. And us being map people, guess what? We got maps that we can make. And we can gobble up lots of space right there. Gobble up lots of space. So I was really happy because we went to the NCGIS conference and one of our students, Chima, is he here? No? Chima, he placed 4th in the poster competition. So it's good. It's good, really good. Okay. And he made just really good visual products because people from physics and chemistry, and they're not going to know all the stuff you're talking about, but they're going to want to look at a nice map that they can understand. You know, and looks visually pleasing, and they don't have to say, well, why do you have A, B, C, and 1, 2, 3, and what does it mean if this is bigger font and this is bold and italics? You know, you shouldn't have bold and italics everywhere. You should be bold and italics where it calls for being bold and italics. And so those are just some of the tricks and tips that I've kind of learned over the last few years, so we can help you. You know, you might get an award or something like that, and that's something to put on your resume. That's something really important to put on your resume. Other things we've got here. So the North Carolina GIS conference, it was this week. I had a good time. Andy went, Daniel went, right? Anyone else go here now? But we took about 7 folks here. We were nice and busy, but you know, we started straight, you know, we started right off the bat with a student named Caitlin. Spatial interpolation methods to best represent air quality data in North Carolina. That was her presentation. Does that ring a bell to anyone? That was like week 1 of this class, you know, and she went through and did some assessment and evaluation to figure out what evaluation technique, and I believe she found it was IDW. Andy like nodding his head. I forget which one it was. It was like the first one. I was kind of hustling from lunch and all this other. And this Korean chicken there was really good. So really good. Okay, but right off the bat, we had some of these here. I had something. Oh, I didn't do this. Andy did this, but I put my name on it. But Andy talked about using Esri hubs to dictate water quality education in Eastern North Carolina. And for that NASA, when those NASA Cup people come next week, I just want you to talk about this because this is applicable to natural hazards. You know, we'll just kind of frame it around natural hazards and having that availability of data. So we don't have to go and reinvent the wheel. But this is the program here over Wednesday, Thursday, and some Friday here. Lots of representation. We've got Andy presenting here on spatial disparities of prostate cancer mortality and socioeconomic determinants in North Carolina from 2015 to 2020. And so this is something I would really like built into a paper that we've kind of talked about, what we'll look at next week with death records. You know, I always thought it was kind of interesting, is prostate cancer going to be, because it impacts so many people, and it's impacted, you know, my family as well. What is the spatial distribution of it? Is it spatially distributed? I don't know, I'd like to see that. What are the you know, because a lot of times I think of it with people that impacted me, and, you know, it's not related to, you know, low income or minority populations or whatever. Or there are other things related to that, you know, above and beyond those, or even access to healthcare. So I'd like to kind of build upon this and look at spatial distribution of prostate cancer. And we'll talk about some of the tools and techniques for that next week, especially the data sources. You know, because a lot of times people say, you know, I want to look at this, you know, I want to look at this relationship between this. You know, I want to look at this relationship between these two things. And I'm like, well, that's great, you know, but I'm not going to sit around while you develop the data to do that. You know, once you get all the data together, we can start, you know, building it. You know, give me 20 years worth of death data. And then from there, you know, all right, let's run a summarize and a join and bring in the zip codes and kind of look at some of these things related to that. But you can see some of the other presentations. These are about 500 people, 600 people. All they do is do GIS work in the state of North Carolina. Really, really good community. I like those folks there. I was kind of running around with some things off of campus, off as well. And then we had a guy named Cameron. You know Cameron?
Yeah.
Yeah.
Yep.
He sits right over here. He was our nominee because we nominate 2 students, graduate student and an undergraduate student, for projects that they do. And they get a $200 check, and they get recognized at the luncheon, and they get free registration. But he did understanding the impact of vehicular incidents in North Carolina, where basically those death records we were just talking about, when you die, there's a little code that you get. And so he just he put together all the death records and said, let me look at car accidents. And he saw that car accidents were really, really high in southeastern North Carolina. You know, Robeson County, Scotland County, Hoke County, all down there. Why? You know, probably a lot more young people. There's a lot more violent deaths down there as well, like shootings and murders and things like that. You know, so what are some of the reasons why? Because remember, in this business here, in this, you know, especially in this class, we're not in the why business. Maybe over, you know, you doing some things with biology, but we're in the where business. You know, so let's not overstep our bounds when we start. You know, we're looking at the where, and then maybe some related factors, but we never try to get, or I never try to get into the why. I'm not a why person. So some really good things here. I had a presentation here on our cemetery mapping project. Maybe I'll present that sometime here. But just lots of neat things here. Another thing that's going to be coming up soon in August or October 1st to 3rd is something called AUG, which is kind of the same type of folks here. This is the North Carolina ARC Users Group meeting. This is a little bit smaller, group, but I took one who's joining us online there. Maybe I'll take a student or two. I don't know, depends, but these are for GIS professionals in the state of North Carolina as well. So I try to be really intentional about, you know, who I take. And, you know, Juan works in the state, so I'm gonna take Juan because he already works in the state here. You know, if you're looking to go to grad school somewhere or whatever, do research somewhere, this probably isn't the place I want to take you and, you know, spend money here. But this is a really good event, kind of some of the same folks right here. They're calling for abstracts, which are due April 18th. You know, and a lot of this stuff is just related to GIS work in the state of North Carolina. So they do a lot of things with, you know, parcels, health data. What do you think the big present thing is these days in North Carolina when it comes to GIS? What's the big kind of, you know, we got parcels, we've got addressing with E911 and all that other stuff. But the whole plenary session, the first session of the talk was like a 2-hour talk on natural hazards, Hurricane Helene, integration of mapping services, location services, drones, all these other spatially enabled services to look at natural hazard responses, because Helene was just one of them. We've got flooding, and so we've got flooding, air quality, water quality, all these other things here. We've got tornadoes here. We don't have earthquakes or tsunamis or anything like that on a regular basis, or even kind of, weather-related events as well, especially we know the response to snow in this part of the state or this part of the country. And so natural hazards, which to me is starting to make a big focus when we talk about that and the impact on people. Because Paul talks about resilience. What does the word resilience mean? Ability to survive and to respond. A lot of times the people, someone like me, I have, my tornado blows off my house. Well, I'm going to go in, I'm going to go into my little basement, call my person and get it taken care of. Some people out there aren't as resilient. And then, I'll go live with my mommy and daddy who have a 3,000 square foot house in snow camp, and I'll be fine and whatever. And my wife and kids can figure out whatever they're going to do. But the idea of, being resilient, and there are resiliency issues when we talk about things like food security. I can just pick up stuff on the way home from work. My wife goes to, Harris Teeter or whatever, and other people, it's got to be on a bus route or whatever. And so the idea of resilience with natural hazards, I think has been really, kind of brought to the forefront with, Hurricane Helene, especially when we're looking at, populations, not urban populations, but rural white populations, but typically poor out in the western part of the state that have been impacted, that have totally different tenor and dynamic related to, some of the flooding that we see in the east and some of the things that we have here. So I like this. This is a great talk here, but one of the things they have is scholarships. Okay, so GIS scholarships, GIS scholarships, but to be eligible for a GIS scholarship, be an attendee of an accredited community college, university in the 2025-2026 school year with a major in geography, GIS, geomatics, because A&T, the person who runs this is from A&T. Not be a previous ARC Users Group scholarship recipient. And this is a pretty good talk. They usually have 2 or 3 rooms, and then they have talks, on the half hour about some of the things they're doing. How are we doing addressing? How are we doing natural hazard response? How are we doing things that are GIS related? How is GIS being applied out there? I think recently I just sent on a job announcement to all of our students for a student who sat in the back, and all he does is the parcel mapping for Durham County. That's all he does, parcel mapping. He got a promotion, and they're looking for his replacement. Maybe it'll be one of us. You saw that one, right, Alon? Did you apply for it? Okay, good. His name's, do you know Zuri? I don't know who knows who in this department. Zuri. He's working for the Durham City doing parcel mapping. Yep. And he just got a promotion, so he sent me a link to his old job that people can apply for. Yep. You remember Zuri then?
Yes.
Okay. He was the geography bowl guy. He
was also with the Quiz Bowl.
Quiz Bowl, yes. He knows a lot of useless information. He does. He knows a lot of useful information, but he knows a lot of useless information. Now, scholarship awards, $2,000, $3,000. You need a letter reference from a GIS professor or the department chair, and you email it to this thing. And I think it has a couple other stipulations. Provide a project example poster, application, or paper which highlights geospatial techniques. The one thing about this, and I think we haven't had as much success as I've wanted to in the past, is because a lot of people focus on the topics while NCGIS conference is doing GIS in the state of North Carolina. It can be applied to a lot of different fields, and AUG is specifically for ARC Users Group. So there's a bigger Esri presence there, as opposed to some of the folks. One of the people that I know I've worked with in the past love open source and QGIS and GRASS. These are just kind of open source software solutions, kind of like the GIS equivalent of ARC. And I think a lot of times people focus so much on the topic and we want to focus on the techniques. Where that we're looking at fire management or access to fires, and people focus so much on how important it is for the fires as opposed to look at all the cool stuff that I did to the data to make these cool maps. And I think we've struggled in the past. I think sometimes some central students maybe, not maybe, they do focus too much about the topic. All right, it's cool, it's a topic. It's like the people who spend 10 minutes, introducing, on their introduction, their introduction on a talk, reminding us how important it is and have to rush through all the methods as opposed to a couple of bullet points. This is what I'm doing. This is why I'm important, and focusing on the maps, the end products, as well as the techniques and data for which you got to those. So, if you want to apply for this, please do so. Just maybe run it by me or Dr. Malhotra or even Dr. McGinn about what it looks for here, because the students have been really, really good. The other thing is that the undergraduate award is $2,000. So you can see the students who got these. This girl Morgan here, she's applying for our grad program. These have been really, really good. But the award is $2,000. It's a scholarship award, and for graduate, it's $3,000. And so if you get it, Ed McMahon is not going to show up at your house with a big check. You guys know who Ed McMahon is? You know. Will knows who he is. These are like, he used to bring like these big checks and knock on your door and like, here's a check for it. Now, they are going to contact the scholarship office, and you put $2,000 into your account. Now, if you have no balance, what can you do with that $2,000? You can take that thing out real quick, but if you do have a balance, it'll be less money that Haven Powell has to, conjure, okay? But it's something really good to put on your resume. I think you get free registration. You get free registration there, and it's a good conference. I took one last year. We played some cornhole. I kind of got used to it. We almost won a game there against the people there, but kind of a good group, good lunches, good, kind of meeting, talking about the stuff, what we do for GIS in the state of North Carolina. It's really, because I think in academia, we do these kind of neat research topics and posters, and this isn't reality when it talks about, natural hazards, E911, zoning, parcels, 3 or 4 people, all they do for a living in Durham County is just work on parcels. We have a student who works on sewers, just sewer lines, and they might not be as sexy or as glamorous, but those are things that are really important. Your sewers, you flush your toilet and go somewhere, and you better hope the GIS person or the planners or whatever are doing their job with the engineers and the people on site and hitting things in the field. I'm talking a lot here, so let me stop talking as much. Okay, so if anyone's interested, scholarships, apply. I like it, and I just make sure you have a good poster, a good application, maybe a paper, maybe something from geostats class. That would be really good. And there's an undergrad and then there's a grad. Okay, great opportunity. This year it's in Asheville, so Asheville's nice. Asheville's a nice little town to go out to. Real pricey, but when someone else is paying for it, it's more than absolutely nothing wrong with that. All right, so today, like I said, I'm going to talk for about an hour, and then we're going to go just because I need to get out of here. Any other things that I'm thinking of here? North Carolina GIS. This was in Winston. This is the call for presentations. You can see the schedule here. And if one of our students get in or get awarded the scholarship, I'll figure out how to pay for your hotel and all that other stuff, they've got a conference hotel, so it's only, $200 a night, and they've got food there the whole time. So it's, you might be responsible for dinner or something like that, but that's about it. So today we're going to talk about FAIR data. We're going to talk about open data. So we're going to kind of take a step back from some of the programming that we've done. And FAIR this is a big thing these days where that there's a lot of grants out there for fair and open data. This is a grant proposal, $600,000. Findable, accessible, interoperable, reusable, open science. And these are all the things we're going to talk about today. So this is a grant I'm applying for like right now. Like I've got waiting for one more letter of support, and I'm going to submit it and click the submit button. And they previously funded me, a project for like $1.1 million. So that helps fund some of their students here. And it's still going to be around because I'm sure we know what's going on with the government, with things getting cut off. And so they think it's important enough that it's, it's not related to GEI or any of the other, buzzwords that are kind of rolling around the government here these days. But $600,000 for 3 years to kind of do stuff related to open data, facilitating. This is important. So they're looking to spend, whatever, 4 to 10 projects times 600, $6 million on helping to facilitate the idea of open data. Open means it's available to everyone, because some of the things we see these days is this schism between, the haves and the have-nots. We see this thing all the time, disproportionate access to resources, whether it's, healthy food, unhealthy food, education, healthcare. We have these things called healthcare deserts. So people have to travel far distances to do that. And I'm sure there's relationships between health outcomes, whether people are just, hey, I'm not putting a healthy food store here because I know the people who live here aren't going to eat healthy. They're still going to go get fast food or whatever, or other reasons. And so the idea of open data so that you can use raw data and do what you want with it, or do the stuff that we're going to do next week with it, is really important. So we have this idea of fair data. This is relatively new, but it means it's findable, accessible, interoperable, and reusable. Well, we know what findable means. Like, am I able to find it here? It's all great if you can't find it, because I go and Google everything. And we're going to look at something called CODE later, which is the Center for Data Equity. Daniel's been doing some work on it. I know Andy's been doing a work on a different hub, because we have these things called Esri Hub technologies where you can just put all your data there. You can store it on the cloud, export all your maps, click little buttons, and it can be available in this hub, and this hub, and this hub, and this hub. But we need to make it findable, because if I have something called NC_counties, you probably know what it means, but we have metadata attached to it. We have descriptions, item descriptions, we have spatial identifiers attached to those. So are those findable? Are they accessible? How do you access those? And so when we look at our hubs, are they interoperable? What's that word interoperable mean? Does everyone use ArcGIS Pro?
Yes.
We work with different operating systems or
Work with different
softwares,
operating
whatever.
systems. So is it going to work with GRASS or QGIS or even CAD? Not ArcGIS Pro, but everything else. If you're not GIS savvy, can you just download the CSV file instead of this shapefile thingy that it asks for, or feature database or whatever? And then the last thing that it has, is it reusable? So can we go back and reuse it? Is there any licenses attached to it? Because a lot of times we hear this big nasty word called IRB. I'm sure you've heard of it over at Duke, right? So dealing with IRB. So if I have data and I've created data, can I create a license, or at least access constraints that say, hey, if you use my stuff, you can use it. Just make sure I get credit for it. I'm someone who always wants credit for stuff. That's my big thing. Okay, and it should be rightfully so, especially if I produced it and created it and curated it for bigger and better use out in the research world and the workforce. So we're going to talk about open and fair data. Another thing more recently has been CARE, especially for, we look at like the Southwest for Indigenous Data Provenance, and CARE stands for collective benefit, authority to control, responsibility, and ethics, because I talked about this idea of IRB. What's that mean? What's an IRB stand for? Internal Review Board?
Yeah, that's right.
Or Institutional Review Board, something like that. Well, why do we have IRBs? IRB is just the worst thing I don't want to deal with, because If I want to go collect data, if I want to go take a survey of everyone, I want to do a project where I measure the height of everyone on campus and I've got to go collect all their personal information. Hey, where do you live? What's your name? All this other stuff. I have to go to IRB on campus. So I get quote unquote permission to go and do that. You know, because I'm collecting individualized information. So one of the good things I like about GIS data, when we look at data collected at the zip code level and the census tract level and the block group level, is that I'm gonna need an IRB. You know, and so the first week of geostats, remember when we mapped all of those, cancer deaths, like 100,000 cancer deaths. Basically, I had to go through and get an IRB for all of those. And then if you look at it, I think I got rid of like the names of people and all that other good stuff. Because it's essentially what they wanted to. They didn't want you to map the cancer deaths, but what they really wanted you to do is group those at the block group level and the census tract level and look for associations, because that person living right there who died, I don't know what their income was. You know, I really don't. You know, I don't know how much they made. I don't even know their race unless I can kind of look that up. But I know in the zip code of the census tract they live in, what the percent minority was, or what the average income was, or what, you know, what the person, you know, the majority of people did for a living. And so we can group those at different scales that don't typically require IRBs, which is much less problematic than having to go through those on our campus. Now, Duke, they probably meet every couple of weeks. Ours meet maybe 2 or 3 times a semester, and they fight and argue and all these other things, you know, and especially, you know, they got a lot of biology with the BBRI and the Bright, so it becomes problematic. But these care principles, there's been increasing concern, especially working in indigenous populations, is that we kind of, people swoop in, they ask questions, they leave. And so just being respectful of the, you know, just basically being respectful of the people that you're getting data from, so that, you know, well, what are you asking me these questions for? Am I going to get something out of it? Like, you know, quid pro quo, so to say, you know, so to speak. And so those are really important. So this kind of idea of care data has been more pervasive in the last probably 3-4 years. I've heard about it a lot more than, you know, the open data, the fair data, because open data is only like 10 years, you know, the idea of open data is only like 10 years old. Like, how dare you ask me for the data which the government paid me to create, and I'm going to keep it for myself. So today you're actually going to look at a project and you're going to create an open science, you're going to create an open data source that has a dedicated URL and DOI, digital object identifier, and you're going to create data for it, and you're going to publish it for one of your projects. And you are going to, that's the homework for this week. You're going to do it. And then you're going to look at some of the stuff that Andy and Daniel have been working with in our code, Center for Data Equity. So I'll talk a little bit about these things, and then we will talk about the homework and call it the day, since I want to get on the, I gotta get on the road early tomorrow. So, but I'm not going to talk about all these slides here, but I did create some neat things about open government data, PSI directives, the whole idea of open data. But basically the idea of open data, open government data, linked data, how these concepts relate. You know, when I worked for the government, you know, there wasn't a lot of open data, especially the military, because we don't want to, you know, you can find the military installation data, then someone else, maybe with nefarious reasons, can do so as well. And related policies, and then some of the directives related to these. And I just kind of wanted to highlight some of these things here, where that we have open government data policies, we've got FAIR and CARE, and these days when you write a grant, they want you to speak to FAIR and CARE. Well, one of the grant programs I'm looking at is called FAIRS, so, you know, findable, accessible, interoperable, reusable, open science data. And what we're looking to do is create metadata standards. We'll talk a little bit more about metadata later, but that's data, store data about data, information about data, and there's formalized formats for that. So when we look at a feature class or feature layer or map, and what's all the information about it, so that I can populate in a separate file that can be searchable and queryable, so that I don't have to look for NC counties. I don't have 3 feature layers of NC counties sitting in my hub. I only have one of them that's called NC counties, and it's got a nice long description that I don't have to create it 3 times because I didn't know I had created and I know it didn't exist. And so the objectives of different, PSI directives, open data. Data's content is open if it's free to use, reuse, and redistribute. And these days, I've got a couple grants that I'm submitting, and at the end of these, they like the technical jargon that I like, but they're more and more kind of talking about, well, how is this going to benefit everyone? How is this going to benefit? Well, I'm going to create my Jacquard index tool, but I'm going to make it free to everyone. Well, how do I know how many people look at it? Is there a way that we can do on the internet to track how many views there are? Oh, yes, that's what YouTube and Instagram and Facebook and all that other stuff is built on. That's been only done in like the last 20 years. Page views and all those other things. Clicks and likes on all those other things. We typically have a fancy word for those called, analytics. So we have this analytics attached to these. So now I can see how many times people have downloaded NC counties or looked at Andy's map versus someone else's map, or which of the maps people looked at and utilized the most. When I was, getting started in the web a long time ago, those things didn't exist at all, not around at all. And so the availability and access to data, we kind of talked about the difference between, availability and access when it came to food security, but it's got to be available as a whole and in no reasonable reproduction cost. Downloading, it must also be available in convenient and modifiable format. And so if we're going to look at our code, our Center for Data Equity, that we store data assets related to NCCU, in particular our department. But I'm going to click on download, and it's got shape files, it's got CSV files, it's got lots of different files so that the non-GIS person can download those, or the zip codes, and at least do a spatial analysis with the CSV files, even though they're not attached to any points, lines, and polygons. Are we able to reuse, redistribute it? So provided under terms that permit reuse and redistribution. So my little Jacquard index tool that someone's going to give me $600,000 to, $600,000 to create, I can't go and charge money for it because someone's giving me money to make it. And then also what I would do for that is create a data hub that's basically a web page that has the places where you can download those. It keeps track of the number of downloads and views, that has training tutorials and all that other good stuff on there. And then only should be or play to universal participation where everyone can use, reuse, no discrimination against fields or endeavors against people. So non-commercial restrictions would prevent commercial use, all these other things right there, even though some of those issues kind of exist to this day. But open government issues commissioned by government or government controlled entities, it's open, that is freely used, reused, redistributed by anyone. And these days, when you write a paper, one of the required elements, has anyone ever submitted a paper to a journal? Yes, thinking about it? You saw your mom do it? You looked over your mom's shoulder when she do it? Okay. But these days, when you submit a journal article, they're going to have information about, you got acknowledgments. You submit the whole paper, acknowledgments, who do you acknowledge? Make sure you acknowledge the people who provided the data as well as your funding sources. That's always going to be important. But you acknowledge, you put, where's the data sitting? You had some really cool results, really interesting results, but I want to go use the data that you use. So you're going to see this breast cancer paper that we wrote, and then the raw data that we had that we created from it. Doesn't have the shape files or anything, but we extracted data, brought it into Excel, and then just ran the statistical analysis on that. So people can replicate that exact thing if they really wanted to, exact technique if they really wanted to. But in some cases, data is going to be sensitive, it's going to be private. And even these days, we use the word data in a very loose, loose form here. Me being a quantitative geographer, I always think of data as kind of a spreadsheet. And then with GIS, one of those records in a spreadsheet is just linked to a point line or polygon. But data can take on a lot of different forms. And a couple of weeks ago, when I was in Puerto Rico, there was a lot more of a focus on qualitative data. What would be some examples of qualitative data? Yeah, well, even qualitative, what's qualitative mean? It doesn't have numbers attached to it. So like recordings and histories and, open answers, open-ended answers, things like that. And these days we got recordings, we got pictures, we got media, all these different things that we can store in a data hub. So with these Esri data hubs, we're just not storing maps and feature layers. I can upload videos and PDFs. And if I create high quality metadata about those will be just as reusable and findable as any of the other kind of mapping assets that we have. And I think that's important. So when we look at kind of government data, we want transparency. We always want social commercial value attached to it. We want participatory government so that people can have a say on the use of it. And so some of that care data, basically when we deal with or people work with indigenous populations, they want people that basically have a say on it. So when we go to Puerto Rico and do work with them, we just don't kind of swoop in like, what do you all want? What do you all need my maps for? And one of the places we're looking at, I might have said it when, last week when I was talking about Puerto Rico, one of the big things is that they get hit by hurricanes a whole lot. And so there's a big push for solar power. So when they're looking at GIS and mapping, it's for where can we put solar grids? Where can we put, solar, because they don't want to be dependent upon government, us, whoever else, or the a kind of overburdened electrical grid. And then reduce government costs. This is important because, we hear about DOGE, Department of Government Efficiency or whatever. I think there's some, there's some truth to it. Just when I look at my own data hub, I probably have 3 separate NC counties data layers sitting there that I've forgotten that I put there, doing the same exact thing, storing the outline of the North Carolina counties. And it probably took me 10 minutes to do it, but that could have been 10 minutes. I could have been watching YouTube or doing something way more interesting, than creating just another NC counties or states layer that had already been existed, but didn't realize because when I typed in counties, nothing popped up because I called it NC County and I didn't put any metadata for it, so it didn't find it. So it's like, oh, you don't have any counties here. Oh, darn, I have to go create another one. So those are important about reducing government costs. And some of the things Andy and Daniel are doing is that we have all these data assets sitting in our hub, sitting on the cloud, and now they can tell me, click a little button. I can click a little button. I'm not writing anything, but I can click a little button and they can tell me everything that's sitting in there. So I can sort by name. Yeah, you got 2 NC counties sitting here, the same exact thing. And they can tell me how old it is. How much of it is missing metadata? Hey, we're missing abstracts for these. We're missing use constraints for these. We got to put in those use constraints, especially with the use and application of these FAIR principles. So it's really important that we do that. Another thing we have is linked data. Linked data is data that's structured on the web using web technologies that's going to be readable by computers. And so what you're going to do today, or what you're going to do for homework this week, is just maybe something you did for geostats. You're going to put one of the data sets that you created for your geostats final project, or something that you've done already, is you're going to put it on Open Science Framework, and you're going to basically create something called the DOI, Digital Object Identifier, which is just slightly different than a URL, but it's going to be unique across the entire web. You already did that, right, Philip? Yeah. It's pretty easy, right? It's really easy. Yeah. So, Philip's kind of jumping ahead a little bit. He was kind of a bit of an overachiever here. But it's a URL or DOI, I probably have to look a little bit more into the difference between DOIs and URLs. Sometimes these digital object identifiers will be specific to things like pieces of equipment and things. pieces of equipment and physical assets as well as digital and virtual assets where that URLs are strictly, virtual, so, residing on the web. But they help you discover more things. And so things like open government, here. So we can look at, forecast, low temperature, high temperature. One of the things these days we start to do are data streams. So we work with air monitors, temperature monitors that are linked to data that are always added to a living, breathing data source. So it takes a real long time to figure out that connection between things like LoRa, long range, internet or whatever that's called, and feeding data. So I can look at the air quality in Greenville, North Carolina at this station for a couple of hours ago, and it takes a long time to set up that connection, but once you do, you're pretty set. It's really easy. And so some of these linked data is that they don't utilize your hard drives and your flash drive. They're just sitting on someone else's computer. And one of the things, and if you notice, one of the things with our Python that we've done, I don't connect to the cloud because I kind of started doing Python before this cloud stuff came out. So Andy and Daniel are really good at connecting to the cloud. And it's really easy. It's like one little command, something called Esri.home or something like that. Home, put in your username and password, and you can access all the stuff in the cloud. Then you can look up the different initiatives and folders that it belongs to, but that's not stuff that I do. So that's why I outsource it to Andy and Daniel, and they do it. And I pretend to know what they're talking about. But at the end of the day, we're just pulling the same exact metadata that we're going to do in a couple of weeks. And when we do look at metadata, instead of connecting to an actual physical database sitting on your downloads or whatever, we're connecting to something in the cloud sitting on some other server somewhere. But the connectivity is a little bit different. So we got open government data. One of the good things about the United States, and actually working with Puerto Rico is part of the US, so like I can get lots and lots of census data. If you go to censusdata.census.gov, you can download just pretty much anything, anything that we answer on the census. What is the number of people from the country of Denmark living in this zip code right now, in 2010, in 2000, in 2020, from the census, the estimated number in 2017. You can think of anything. Now, with all that data, what's the trouble with all that data? There's a whole lot of data that you got to sift through that's absolutely useless. And so some of the stuff that Eric in the back and I are doing are, we're looking at school attendance rates, EOG scores. For what grade are we looking at? 7th grade?
Seventh grade.
Yeah, 7th grade. Now, do you think they just say, hey, here's the school and 7th grade EOGs? Oh, no. No. They have 5th grade, 6th grade, 7th grade. They have a whole, and they have them by row. So now they have 5th grade boys, 5th grade girls, 5th grade white, African American, Hispanic. So for each school, you probably have a couple hundred records just for each school for the different cohorts, the 1st through 7th grade. It's different. Some of the schools are like 1st to 7th grade, and then you got your middle schools, you got your elementary schools, which have different LEA codes, which are basically 820 numbers for schools, unique identifiers, which form a concatenation of the county name or county number with the actual school. So everything in Alamance County would be like 010023, 010025. But some of the challenges that we run into when Excel sees something that's like 01223, what does it think? Oh, that's a number. Why do you have that 0 there? Let's get rid of that 0 for you, and let's make this a number for you. Oh, 10,002. Oh, you got a leading 0 there. And so Excel is sometimes too smart for its own good. And so you got to deal with some of those issues like that I don't want to say I don't teach in this class, but it would be we deal with on a case-by-case basis. I would love to sit down for half an hour and kind of go through those. But next week we'll kind of look at some of the the issues we deal with, misspellings, spaces, all those other good things. Open government policies. These are just some examples of, the European, and these are just some organizations, because to me, I think Europe's probably a couple of years ahead of kind of data governance, open data, all those other good things. But to me, I like the continuity of the United States with the census. You can find anything everywhere. North Carolina is one of the strongest states out there. North Carolina has something called nc1map.gov. It's got, you go there, you type in the word swine lagoons, it's got it. If someone created it one time. Streets, parcels, you can get any parcel. The parcel that you live on, you can go and download it for your entire county. Now, we have parcel viewers in Guilford County over where I live. I can go look at my little parcel, but once a quarter, those things get uploaded to NC1 Map or the NCGICC, North Carolina Geographic Information Coordinating Council. And those are people who run GIS in the state of North Carolina. Those are the people who put on the conference. That conference happens every other year. That's kind of like my Super Bowl, every other year Super Bowl. Like that's my top dog, and that OG thing, I'm starting to get into that too. Why? Because I want you all to interface. You're not going to go do Washington GIS or Montana GIS. You're going to, hopefully most of you get into North Carolina GIS. So these people are really great conduits because they're starting to look like me, old and gray and all this other stuff. And they're going to need young blood to go and replace them. And why not anyone? Why not you all? No, you're just as good as anyone and everyone else. And so, I like going to these things, I like going to these things locally. Now I'll spend my own money and I'll fly across the country, but I will not fly David across the country to go these things here. I'll fly myself to Puerto Rico, but I will not fly anyone else to Puerto Rico. So we have open data. These are some other things here. These are some of the U.S. executive orders, open machine readable government. So we got openness, strengthens democracy, promotes good services. We release data that's easy to find, accessible, and reusable, and we ensure safeguarding individual privacy, confidentiality, and obviously national security. So some of the stuff we work with on the military was stored behind, firewalls and servers, and I'm not even sure how they do this now. But we got lots of different countries out there. For Sweden, Estonia, France, G8. We have an open data. How do we foresee it? What are some of the local administrations? And there's been some really, North Carolina One Map is great. Go to North Carolina. Eric and I are working. I'd go download schools. It's got the LEA for the school ready to go there. So when we get those EOG scores, all we're going to do is a nice tabular join as long as the data is ready for us. And we can make graduated symbol maps on EOG scores and attendance rates, because what we're trying to do is find an association, or more importantly, my hypothesis, is there an association between school attendance and EOG scores at the 7th grade level? Do you think there is? Probably. What statistical tests am I going to use to do that? And it's not a two-tailed t-test. I love that two-tailed t-test. But how can I find the relationship between two things, two variables? Correlation, simple correlation. Graph them. It'll give me a p-value and it'll give me an r-squared. Give me an r-squared. And look at those together. And we talked about those scatter plots. We look at all those points up there. What are the chances that these points here are random? If they kind of go in one direction, I bet you they're not random. There's some relationship between those. And that r-squared talks about that closeness to fit for a line of best fit. So I got some case studies right here. Belgium, Denmark, France, UK pharmacy, European energy. One of the other things that I thought was interesting, just thinking about it, the North Carolina GIS conference, and then we got a online student, he's taking this class, Kareem here, looking at solar energy potential in North Carolina, just with the cost of energy. I think the other month I had like a $500 energy bill, and I got propane, I got propane in one place, I've got electric up there, and it's just like, I don't wanna pay $500, like, you know, solar, let's look at solar, is there solar? What is the idea? And so this whole idea of solar, and then, places like Iceland, been there, what do they use? Geothermal. Because solar really isn't an option because, well, half the month it's pretty dark. And the other half, the sun's up, but it's at a really low angle, so it's got a lot more atmosphere to go through, so it's not going to be very powerful. So we've got open link datas, PSI directives. That's about it here. Now, a couple things I want to show, and then basically I'm going to talk about the assignment if that's okay, and I can get my 4 hours of sleep here. So now a couple of the data initiatives that we have, I'll talk about North Carolina One Map first. This is North Carolina One Map. The one thing about North Carolina, and I've talked to a lot of people about this, is that at the state level, to me, like, what's that? Who did that? My screen. Okay. Duplicate. Oh, that's why, because I stopped it. But let me get this real quick. When we call this like North class, because she knows our class. I'm just get scared. If I don't answer, she's gonna yell at me. But that's something for my therapist. Okay, all kidding aside. One thing about North Carolina is they're run by something called the North Carolina Geographic Information Coordinating Council. To me, North Carolina, and I've lived in a few different states, kind of gotten used to some of the different states, probably one of the most organized states when it comes to kind of top-down GIS use. They got a guy who runs GIS for the state of North Carolina, runs it. His name's Matt. He's a pretty good guy. And then there's another guy, and his name was Tim, who's kind of starting to retire. But these folks run GIS for the state of North Carolina. And this is an open data hub. So it's got different apps right here, so we can connect to different services. To me, these days, I'm still a little old school, basically meaning that I want to download the data, put it on my computer, and utilize it, even though it's going to be updated in 3 months. But we've got One Map, we've got data projects, we've got help, we've got metadata. This is data about data. Do these videos look familiar? Fine. So the grant that I have right now, look at this guy's name here. I'm right here somewhere. I swear I am. I really am. Metadata committee. There I am right there. Yeah. So the last metadata standard. So the grant that I'm looking to do is basically update all this metadata, because it's about 10 years old. And in the computer world, 10 years old is really old. So I can pay someone $75,000 a year to go do this, and I can get credit for it. It'd be great. But all these techniques here, they're pretty cool, but a lot of these are going to be antiquated. But all kidding aside here, I can go and type in the word swine lagoon. Or actually, I'm going to type in the word school. And this is an open data hub, which basically means, I really know what I'm doing. Come on. okay, public schools. So this is a GIS data layer of all public schools in the state. Now, if I look enough there, I can probably find a service, a URL that I can connect to, because I can go to something like data.services.nc1map.gov and connect to those through my ARC catalog, my little ARC catalog, how we manage data. I don't like to do that just because I like to connect to the imagery because I don't want to download imagery. You can connect to 1993 imagery and the latest and greatest imagery. But I can click on, and you click on download, but I can, zoom in, and this is over where I live. I live right around the corner from these here. So I can click on the little county and it says Northern Guilford High School. It's kind of funny because this isn't the high school. This is the high school, but it says it's the middle school. So it's kind of swapped them. But you can see all the attributes kept about them. Now, what are some of the wacky things you see? The zip code is 27,455. It's not. That is what? That's alphanumeric. It's 2,000, it's 27455. But when we bring these into ArcGIS Online, which is, to me, is just more of a dumbed down version of ArcGIS Pro, which is very powerful. It just thinks, it assumes that it's a number. And it's not. And you need to go specify it because this was probably created in ArcGIS Pro, and we export the maps and services, because up in the top right in ArcGIS Pro, there's a little share button. You click share, you pop it to the web, and it's got a brand new, unique URL that you can share with people. You can put into web maps. I can say, hey, schools, make it editable so I can go around and, hey, I found a new school, or I found a new whatever, healthy food store. I can do my QA QC between stuff sitting in the cloud, stuff sitting on here. That's literally instantaneous. And that's kind of what we do in our field mapping class. That starts May the 5th. So I'm just getting another plug for that. And me and Dr. McGinn will pay tuition, in-state tuition for people who take it. I'm trying to make eye contact with Philip and Mary and Kimberly.
It's for, we're done.
Bill and a lot. You taking that at the graduate level yet? Okay, you'll be taking that. Okay, and David. You what? Okay, I'm making contact with you so that you take it as well. And let me make eye contact with all of you there to take field mapping class. Okay. Now, I still have money to pay for tuition. What's that? Yeah, we pay the tuition, not the fees, but Haven should probably pay for all that stuff. Okay.
I'm just asking if we can make it a 3 hour.
It is a 3-hour class. Yeah. Yeah, it's a 3-hour class. Yeah. 3-hour class meets 9 to 12, and we're gonna have some of our partners from Puerto Rico come, a couple of undergrad kids, or they might be graduate students, come and take the class. So I'm kind of excited about that. Really nice kids and really nice kids. So we're trying to get them over here. But we can see these, but right at the beginning, we got the LEA, local education area. So this is 410, 48, 488. And if I want to, and this is what I always love to do, I click on download, and now I can download these as shapefile. Shapefile is basically just kind of old school feature class, bring it in, add it, and then I can export it to my little database. But I have something here called GeoJSON. GeoJSON, I don't really use these very often, but this is geographic JavaScript object notation. And so it's got like all these tags in those. I haven't really had a need for GeoJSON. It also has CSV. What's CSV stand for? Comma separated values. So I can just download this as a CSV. It's not going to be attached to any points, lines, or polygons, but maybe if you're doing swine lagoon analysis or something like that in R or whatever, you don't really need to do that. And then I got KML. What is KML for? What is KML? Those work with, that stands for Keyhole Markup Language. Those work with Google Earth. Google Earth. I'm not a big person. Michael, is Michael taking this class or he's just TAing? Oh, he's TAing my other class. But Michael who presented last week, he's really good at KML stuff, right?
Yeah.
Yeah, he's really good at KML. I saw him doing this. I'm like, I don't even know what you're doing. But it's cool. But, and mostly you realize, like, the more you start to learn about this mapping stuff in the cloud and even your skill set, you realize how much you just don't know. You know, and yeah, it's just how hard it is. And we kind of lean on experts that we have here, kind of tap them for what some of the great things they can do. So I can click on download. There's a lot of files here, so depending upon the time of day, it might be, it might be hard, but this has got everything that I want here. It's got metadata, and if I go back, I clicked a little more information, full details. Starting to crash things here, but you can see it's got some metadata here. I can open it up in viewer here. This is the old ArcMap Classic. These might not work because these were kind of created with like old school, old school data, but I can download these things here, and here we are. Here's a map of emergency medical services. So you might have some things here that people already need. Public libraries. Now these are maps. If we look at this thing here, this thing is what we call a feature service, which is kind of like a feature class, a feature class online. And so some of the taxonomy is a little bit different. I always use the word layer, but layer has a different connotation in that it has a symbology attached to it. But, we have coverages, shapefiles, layers, feature classes. To me, they're all kind of the same thing, but they aren't. So I type in the word school, here it is. Now, where was I really going here? But you can see all the data assets. So we've got a couple of feature services. These are just things that layers that I can pop onto a map and do my own thing with, where that if I looked at emergency management, they have their own map ready to go. And so they might not give you access to individual layers and say, hey, here's my online map. Here it is. And so it depends on if it's a web map or web app, or if you can access the URL attached to it. And this is where I'm still learning about this stuff too, because I was doing command line stuff when I started this. I was downloading stuff on shape files, turning stuff, my CSV files into lat longs, into GIS. So, the evolution of these is still, to me, it's still learning. Another thing that I think is interesting is parcels. I type in the word parcel. Okay, these have polygons of every single parcel in the state of North Carolina. Every single parcel in the state of North Carolina. Too many to load. I can click on download. And if I click access download parcels one county at a time, I can go to this little, here we are, direct data download parcels. And now I can download parcels by county as centroid and as polygons. As centroids and as polygons. So this is pretty cool here because some of the neat things we do, I go to my Guilford GIS, these are things, these are the type of applications that we use. And these days, these maps are like starting to turn into legal documents here. You can see the high schools that I was alluding to. I went running there like at 3:30 this morning. I couldn't sleep, so I went running there. But I have a little house. I have a house here. And recently, last couple of years, we got a survey and separated them into two different properties because my wife wants to build a house on this. I'm not sure if she wants to build it with me, but that's another issue in itself. But we built, we have a house here, 1947 farmhouse, and then we split it. And so you can, raise the value here. But there's GIS people who do for a living. Someone had to go and create this brand new ID because you notice these IDs this ID is different than all the ones around it. Why? Because it's a brand new one that was created in 2023, as opposed to when these were all created and starting to get automated when it was brought into GIS in the late 1990s. So got this in, and you have to populate all this information. I was given a brand new address. So it's not 119 anymore, it's 117. And of course, I get to pay taxes on this piece of property. Get to pay, they get a $600 bill, they get a $600 check every month or $600 check at the end of the year. So they get about $50 a month. Just a nice little check here. And we got this one here, so 119, 117, but it's got, assessed value, 115. I'm sorry, 115. So maybe my wife will want to like make a little parcel there to make it 119 or 117, and I don't want to give her any ideas. But all of the lot size and all these things were, recalculated, and you can see us right there. But there's someone who does this for a living, and that's what Zuri did that's what he does for a living in Durham County. This is all he does. We got new geometry, we got new attributes. You go and change all these. Always updating these applications. There's probably 3 or 4 people who do this for Durham County. Guilford County is a little bit bigger. There's probably 4 or 5 people who do this for a living, probably starting at, $48,000. The manager probably makes, $80,000, $90,000 just managing this GIS, as well as, hey, we need to store, they're not just sitting in a big shapefile. How do we store these? Because I click on it, that information pops up like that. And so some of the fine tuning of the, algorithms and all that other good stuff, fine tuning of all the other algorithms and stuff. So who wants to download all these? Oh, I would love to. And so I can go to Open Data website, download all those parcels. There's values, and some of the neat things people have done where we get really tricky with housing values. People don't like housing values being published or what you sold your house for. But it's got all of these have tax values attached to those, which I don't want to say just as good. So now we can look for all residential tax values. Okay, let's see if there's association between those and access to transportation or whatever, because you don't have your home value on census. We don't have that home value on our census. And so you can think above and beyond some of these things here. This is a really good site. I'll show one other, and then we're going to have homework, and we'll go with this. This is code. This is the Center for Data Equity. I'm trying to change it to Center for Data Excellence because this word equity is a no-no word these days. And so maybe in 4 years, it won't be a no-no word. But, at the end of the day, what do you want to do? You want to do stuff so you can get money. I hate to put it that way, but my line in the sand isn't going to be keeping the word equity there and me getting turned down grants. I hate to say it, it's not my line in the sand. And so we might need to change this. And I'm looking at Daniel and Andy right there, and he's nodding his head. So, so they might have to change the word equity to excellence. So. Okay, but we also have the same type of hub right here. So this data hub right here, where we have all of our cloud data. Essentially, I just click a little button on a data asset, which could be a PDF document or whatever, and says, make it available for the Code Hub versus another one that Andy works with called COPE. So we have Code and COPE, just they kind of look the same, but that's coastlines and people, and we turn that into something called the North Carolina Community Information Portal. And so we can kind of allow the same data resource without having to create it twice, residing in the cloud, available for 2 different things, available for 2 different hubs. We got blogs, maps, and applications. We got our open data. So I can type in like counties, type in the word counties, and you can see all of the NC counties that I was kind of alluding to before. Yes. So we got North Carolina counties. We got North Carolina County State Plain. And so Eastern North Carolina, Pam. Some of the things that Andy's been working on is creating high quality metadata, because it's called North Carolina counties. Looks good, looks very good. North Carolina counties. Is this the right one here? Yeah. Oh, this is a feature service. Yes, this is a feature service, North Carolina County State Plain. I can click on this as well. And then I can go and download this thing here. You can see all of the metadata, so it can increase the discoverability of it. I can open this up in ArcGIS Online. It'll have a little bit more robust metadata. And then later we'll talk about what really fully compliant FGDC, Federal Geographic Data Committee data looks like. I can filter these, but to me, at the end of the day, I want to download these shapefile GeoJSON file geodatabase, feature collection, put it into Excel, geo package, data source. I just allowed any download to anything. Is that what I did?
Yeah.
So that in North Carolina one map, they don't allow Excel, is that right? Okay. Well, because Excel, when we looked at North Carolina one map, it didn't have Excel. And that might be because they want to be somewhat software agnostic. It didn't even have feature data sets because you can open up shapefiles in other software applications above and beyond. I use them for something called GeoDA or CrimeStat. I use it for something called CrimeStat, which is a statistical application out of the University of Michigan that does strictly geostatistics. And they ingest or they allow shapefiles, or they work with shapefiles. And so I probably somewhere along the line, I didn't care. You can download anything you want. I don't even know what an SQLite geodatabase is, but there it is. I haven't worked with these before, so I can download these as well. So we're going to look at the homework real quick, and then we are going to get out of here. So before my wife calls again. So I'm not sure what she wants. Art, did I just get rid of everyone here?
No, I think we're seeing.
Okay, you're still here. You guys don't see my wife there, do you? I'm just kidding. All right. Nonetheless, when we look at the homework, we're gonna have 2 assignments right here. It's not 2 of them, but they add up to 10 points because we have our daily assignments that add up. So when we look at the week 7, it's pretty straightforward. I have exercise number 6, where week 7, and basically the exercises are, first one you don't have to do. Okay, first one you don't have to do because the open transition to open science, we call it TOPS, is not available. Is not available right now, but I would like people maybe at the end of the semester when it gets available again to take it. It's just transition to open science. What does open science imply? And I think just you taking the class makes people or tries to get you more cognizant about when you finish a project, you publish it, because when you write that paper at the end, it's going to say, where's your data located? And you better have a place where it's located, and the days of email the author or contact the author for data access, those aren't working anymore. Okay. Other thing we have is something I call it an ORCID, but it's basically like a unique identifier for your research that pulls from multiple databases. And so I've put an ORCID because to sign into transition to open science, so you can see my ORCID, it's got 001-933-9641, but it's got it goes through every so often and finds papers that I've never done this. I've had papers here that I've had. But when you sign into research.gov, which is basically NSF, you're going to need an ORCID. When probably NIH has requirements for an ORCID. So go and get yourself an ORCID that you can sign into some of these things with, because that's what I need to do for Open Science Framework. And so don't worry about the first thing. The second thing is Open Science Framework is a tool that promotes centralized workflows by enabling capture of different aspects and products of the research life cycle, including developing research ideas, study, storing, analyzing data, URLs from a prior project, put your open science data up there. And so we have something called OSF. We have something here called OSF.io. I think it's called OSF.io. And what you're going to do here is you're going to get yourself a username and ID. We all do the Spotify. We all know how to do that, right? I think students are much better at it than me. Get yourself a username and ID, and you're going to, oh, look what, You just put some stuff up here. This is Andy. Yep, me. Oh, I'm a contributor. Oh, this is all me. I thought I was something special here. But you can see some of the stuff that I've put up here. But OSF stands for Open Science Framework. There's lots of other, like NIH, NSF, they have things called like Data Commons, Ag Commons, for USDA that you can put your data assets up on as well. I like Open Science Framework just because it's not favoring anyone else, but every so often I'll go to my Pharos meetings and they'll say, hey, we've got, Hum Commons, Humanities Commons, Library Commons, that you can put all of your former papers and all these other things in here. But what you're going to do here is you're going to create a profile. You might need an ORC ID, and then you're going to put a project up there. And then in the discussion board, you're going to put a link to it so that I can go and download it and look at it. I don't care if the data is any good. I don't care, but I want it discoverable so that other people can, if I want to search my projects or I want to go look at all the projects there and I want to find something on fire station accessibility in Durham County, North Carolina, I'll be able to type that in and it'll show up so that I don't have to go and recreate because I know someone has already done it. And so this is a project that I created. This is with a PhD student where we found geospatial associations between female breast cancer mortality rates and environmental socioeconomic factors. And while I'm thinking of it, Andy, that project we did with prostate cancer, I want to just replace the word female breast cancer with male prostate cancer mortality rates and environmental socioeconomic. That's all I want to do. Okay. Because my goal with my PhD students, you get papers. Get a paper done, you're done. There's no qualifying exam that I can give that will not match you writing a paper and someone saying this stinks. Why'd you make me read this? Redo it. Meaning not me, but someone submitting it to a journal. And I've had that happen to me before. I don't do that to other people. I just say, I'd strongly suggest you do this. And if they're like my kids, they say, well, he just suggested it. I'm not going to do it. So forget him. Just forget him. He just suggested it. But I still would say, no, I will not, you didn't do my suggestions. But those are important. Those are important. But you can see what I have here. I put my little abstract right here. And then, put my little abstract. And then I have under here, I've got the data for it. And I made sure for this class, I went and completed it all because we'll talk about metadata later. There's a lot of kind of social issues with metadata, not social, but it's boring. And we don't want to do boring stuff. We want to go do all the cool stuff and the analysis and the reds and the blues where the people that I met with last week, they do the boring stuff. They make sure the roads are connected and the speed limits are correct. And Mulroney has his 115 NC Highway 150 West. That's different than the 119 NC Highway 150 West, even though no one else cares, but it's really important for tax assessment, zoning, and all those other purposes. So you can see the metadata right here for this. And so what you're going to do is you're going to create a project. Now it's got the little pencil. That means I can edit it, but you can see the funding support that I got. I attributed my funders, Pharos, NASA grant right here that I have, and it's got a nice little DOI, Digital Object Identifier. So I can open this thing up and it's got a DOI attached to it as well. It's got, if I go up to the top, it's got files. These are the actual files. Now it doesn't have any GIS data, but it's got the t-test that we ran. So we created hot spots and cold spots of age-graded female breast cancer mortality. What does age-graded mean? So it's not sorted, normalized by age. And we had a presentation last week where someone did mortality, and basically whenever you're mapping mortality rates, who dies at higher rates than other people? Old people. So when you map cancer mortality, prostate mortality, you're basically mapping the old people. So you need to basically age grade or normalize by age. Basically, you do weighting. Remember all those weighting? We did those weighted percentages. You weight by age. Okay, so we got to break into different cohorts and it gets a little convoluted. And so that's why we need to get really big sample sizes, maybe not 5 years or 1 year of prostate cancer or cancer mortality. We need 20 years worth of it so that we have 27 people who die or 16 or 106 as opposed to 1, 0, 1, 0, 0, 1, 1, which will make your rates go really high or really low, or they might double. I go from 1 to 2, my rates double. No, they just went from 1 to 2. And that's why we talked about circumventing some of those issues before. But you can see deaths by year. Okay, so these are all the number of deaths by year, females by year summarized. You can see some of the data sources that we utilize. So some of the people wanted to run that analysis for those results that's sitting right there. And so the expectation for this assignment is that you go to Open Science Framework, you create a profile, create a user ID, and then you go and create a nice little overview of what I'm looking at. And it's going to be submitted in the discussion board. And so we have an overachiever in class who's already gone through and done this.
Man.
He's setting up a high bar, real high bar. Okay. It was supposed to be due 2 weeks ago. So it's my mistake.
Because I emailed you and I told you that the first part, what we have to do the lecture, not the lecture.
The training.
Training.
It was on-
Yeah.
But that was after I already did.
Okay. I was in Puerto Rico at the time. I was it was spring break. I was on the beach. I was in the pool. Well, you got it done. So thank you, Philip. Sorry about that. Yes. So he's got everything up there ready to go. And so the expectation is that you'll just reply to this thread, and then I'll grade it out of 7 points. It's pretty straightforward. And so just reply to it. And then the next question is, and so this will take a little time to go through, navigate the page. There's not a lot of technical stuff that you need to do, but you need to be able to explain the data that you're posting there. So if I go through it and type or search, or someone else does this, they can do that. Also, on an NSF grant, we have code, Center for Data Equity, hopefully Center for Data Excellence soon. We have a hub. Basically, what I want you to do is go through and look at the hub here. How many feature services are there? How many PDF documents are there? We're always adding to this. And so when we go to this Open Data Hub right here, and if I were to click just enter right here, you can see to the left, show 13 more. You can see how many images, web maps, feature services, story maps, hub pages, links, PDF documents. So now you can just see how many PDF documents, because some of the things that I've tried to do is post some of my papers up there. Some of the papers that I have up there, put them up there so that you can go and download, so I don't have to email them to anyone there anymore. And so I've got PDF documents, I've got document links. The word document links and documents are used slightly differently in this as opposed to the contemporary. We got images. So I don't even know what these images, I don't even know if I want to open up these images, but okay. Yep, I know what these images are. These are from story maps that we've created. So we got some of these images sitting right here that we can look at. These were imported as part of story maps and web experiences. So these are field sites for NCDOT projects that I had a student named Mike Wallace who works for the DEQ, who did. So these are all linked in the cloud to a map. And so these are all funded projects from the NCDOT. And so what I ask you to do is just go through, play with this hub a little bit, and tell Andy and Daniel what needs to be corrected. No, don't do that. But go through, look at these. They've and Chima, who's sometimes here, they've done a really, I kind of joke here, but they've done an amazing job on this. They're the experts at working with hubs, and creating visually and aesthetically pleasing hubs. Because with web pages, if you don't like a web page, what are you going to do? You're going to click the little X in the top and go somewhere else and spend your time and money. And so there's a whole qualitative, sociological, psychological component to creating high quality web maps that, you know, people spend lots and lots of money on marketing and psychology to do that. So the second part of the assignment is to just go and answer a couple of questions about it and answer a couple of questions about it, just to make sure you're able to utilize, you know, really specific and intentional information within our web hub. Okay? Any questions for me? Can we be out of here now? Is that okay? Any questions? All right, I'll see you all next week. Next week, we're gonna get into some more technical stuff with big data and death rates. So we'll kind of, good luck at GERS this week. I will be gone. I'll be kind of cheering on everyone and we should be good to go. All right, see you all later. Yep, oh yeah.
Yeah.
I gotta be up in less than 8 hours. It's gonna be a long day.
Usually you're gonna be that once you take off. And
Yep, that's the plan.
I don't know about that. Skip the breeze on the shot.